In section B, you often have to produce a diagram to represent some data. So in a previous recording, we considered the lovely stem and leaf diagram. Sometimes you might be asked instead to produce a histogram. Again, this is a diagram to represent the frequency distribution of a particular variate. So the key distinction between a histogram and a bar chart, because people often get these things confused, is that in a histogram the bars must be adjacent to one another. So just very simply, suppose your histogram ended up looking something like this. Okay, so all the bars here are adjacent to one another, so this is our histogram, whereas a conventional bar chart, bars would typically be separated. Okay, so but it's more likely you'll be asked for a histogram rather than a bar chart, so we're going to focus on this thing. Okay, so your bars must be adjacent to one another. And the other key point of a histogram is that this is drawn such that the area of the bar denotes the value, not the height. So the point is the rectangles are drawn above a particular class interval, as we see here. So this will represent one particular class, this another, this another, this another, etc. And these rectangles are drawn such that the area is what we call proportional to the frequency of the observations. So the key point of a histogram is to say that the area is proportional to, and we use this symbol to denote, is proportional to the frequency of the observations. It's abbreviated to OBS for observations. So suppose you have a particular data set. What you need to decide on is to define your categories that you're going to use. And each category you will then compute its frequency, i.e. the number of observations within each category. Now, a good piece of advice when you're doing a histogram, because it's the area which is proportional to the frequency of the observations, a good idea is, if possible, construct your histogram such that your class widths are all of the same width. Because if these class intervals or category intervals are of the same width, then the height will be proportional to the frequency of the observations. So it's much easier to construct the histogram by having equal width categories. So suppose, for argument's sake, my categories were 10 to 19, 20 to 29, 30 to 39, and 40 to 49, for example. And suppose my observations just take integer values, therefore any observation will be in one and only one of these categories. Because notice all of these categories, these are non-overlapping. So, for example, if I had the number, an observation that was, let's say, 22, then 22 would belong in this category and no other category. Okay, because the partitions are possible values that the observations can take into categories such that any observation will be in one and only one particular category. So work through your data set and just count the number of observations within each category. So you might have, for example, 4 in the 10 to 19s, 8 in the 20 to 29s, 10 in the 30 to 39s, and let's say 5 in the 40 to 49s, or something like that. Again, similar to the stem and leaf diagram, the whole point of producing a histogram is to be able to look at the underlying shape of the distribution. So just as with the stem and leaf diagrams, we needed to make sure we didn't have too many or too few stems. In the histogram world, we also don't want too many or too few categories. Okay, because by having too many or too few, then you lose the shape of the underlying distribution. So we are not going to achieve what we want to do, which is to see what the distribution looks like. So again, as a rule of thumb, maybe 7 to 8 categories might be a good idea, but you'll just have to use your own intuition for a given data set to see what would be suitable. Have a look through textbooks, past papers, to get to see examples of these histograms and see what category widths and the number of categories is sensible for a particular set of data. Okay, so just to maximise the number of marks, just as in the stem and leaf diagram example, there are certain ingredients which an examiner will be looking for your histogram. What are these ingredients? Well, as always, you need to give your diagram a title. And again, make sure it's an informative title. So don't just say histogram, related to the actual data set you've got, if it's forecasts of inflation rates or whatever. Okay, make some reference to that. Also, you need to label your axes appropriately, and notice that your y-axis, the title will be frequency density, not just frequency, and that's because of the fact it's the area which is proportional to the frequency of the observations. And you will have your category intervals on your x-axis as well, so make sure you have suitable labels there. So your x-axis will be related to your category values, whatever they may be for your particular example. Also, presentation, as always, is very important. Make sure your diagram looks nice and neat. Particularly for histograms, very often you will be provided with some graph paper in the examination booklet. Make use of that. It allows you to produce a much more accurate diagram than just drawing it freehand on your usual in your usual answer booklet. So just to emphasize what are the key points of a histogram. Make sure your bars are adjacent to one another. Remember, it's the area which is proportional to the frequency of the observations, not the height. However, if you are clever enough to construct your histogram such that your categories are of equal width, then you can get around this by saying that therefore the height will be proportional to the frequency of the observations. So have a look through some past papers and through textbooks and see examples of histograms. Again, there's usually quite a few marks available for these sorts of problems in an exam, and typically there's nothing inherently difficult with producing these things. Just remember all the various elements of titles and axis labels, etc., and you should gain a nice lot of marks.